think we'll begin. So I just wanted to start off. I think I'm recording. Yes, I am. Okay. I just wanted to start off by going over my weekly post from this morning, and I updated it just now. So there's my office hours, and over these next 3 days at 7 p.m. during each of the extra help hours, I will do a mini review. So today, I'm gonna do a little review of polynomial and rational, just a couple questions. Tomorrow, I'm gonna do the logarithmic exponential, and then Wednesday a little bit of trig. I do have the review questions that I'm going to do linked on the weekly outline. So if you are joining, you're more than welcome to look there just to see the questions. And of course, the recording will be there after each session. Just a friendly reminder about the summative task. It is due Wednesday, this coming Wednesday, January 7th, 11:59 p.m. like usual. Thank you for those who submitted early. Please submit on time. We are, getting to the end of the course. We just have really this week, and then our exam is next Monday. So I don't really have time for chasing. I have to get things marked and then marks submitted. So we need to be on top of things for the next final few days. And then our final exam in person, of course, is on Monday, January 12th. It starts at 6:30. It Although we have the full 3 hours available, the exam is not designed to take 3 hours. It's designed to take maybe an hour and a half. But if you do need extra time, you can continue on until 9:30 if needed. And I did get confirmation that we will be in room 103 at the Education Support Center. I put the address there. It's in Aurora. And I also updated the post just now with the exam format. So we have 50 marks total. 7 questions will be multiple choice, fill in the blanks, and then 9 long answer questions. Okay. Oh, no worries, Ralph. Hopefully it gets results. And then I linked just the same thing I linked from before the break, but just a few exam review documents, PDFs for you. So feel free to do however many you would like. Of course, with math, the more practice you do, the more successful you can be. So yeah, the exam should not have anything surprising on it. If you review everything, maybe redo some old tests or quizzes, or no, the tests with the PDFs. Feel free to do that. The first overall MHF exam review is very detailed, and then graphing was a big part of the course, so you'll see some graphing questions in the second document. If you do both of those, I think you're in good shape. But of course, I always put more for those who want to be extra prepared. So that's there for you in that post. It's also linked on just the weekly outline that we have. Okay, but I'm going to get into tonight's review. Like I said, I'm going to do a little bit of polynomial and rational. I'm going to start off with graphing. So I have a function here, f at x. I've given us this function in a factored form, just so that I can make it a little bit more interesting, so we can recap a few more things. Remember, when your function is in factored form, it gives us our x-intercepts really nicely. And depending on what the exponent on that factor is, we will know if our function is passing, bouncing, or has a point of inflection at that x-intercept. So for this, the part at the beginning that says negative 3x, the x-intercept is 0, 0. It was to the power of 1, so that's a pass. The next bracket, 2x minus 3, remember you're just isolating for x, so the x-intercept is 3 over 2, comma 0. Because it's to the power of 2, that is a bounce. If you don't remember how to get the x-intercept when the bracket's a little fancier, just remember you're setting the bracket equal to 0 and isolating. So bring the 3 over and divide by 2. Then for the next bracket, it's x plus 5. So the x-intercept is -5. Imagine bringing the 5 over to the other side. Because it is cubed, it's a point of inflection. So it kind of looks like a little staircase where you take a little pause and then continue. Then the x minus 4. The x-intercept is 4, 0. That's a generic pass. And finally, for x plus 3, it's -3, which is a bounce because it's an exponent of 2. Because one of the x-intercepts is the origin, that's also the y-intercept, so I don't have to take an extra step to solve for that. But if I did have to solve for the y-intercept, I would just set x equal to 0. Now, I'm going to start on my graph here just by plotting the x-intercepts, but I am going to need to figure out the overall degree of the function and the leading coefficient. So I have an x-intercept at 0. 1, 2, 3, 4. 1 at -5. 1 at 3 over 2, which is 1.5. 1 at 4. And 1 at -3. Okay, I also like to make a note of the behavior just so it's a little faster when I'm connecting the dots. Okay, so here we are. Now, to figure out the overall degree of this polynomial, I have to add all the exponents, including the invisible ones. So 1 plus 2, 3, plus 3, 6, 7, 8, and 9. So it's an odd degree, which means our end behaviors will be opposites to each other. And because the leading coefficient is negative, I don't care that there's a 3 out in front, I care that it's negative. That means we're going to start from quadrant 2 and go towards quadrant 4 to have this overall downwards trend, which tells me that as x approaches a negative infinity, y is going to approach positive infinity, so this way. And as x approaches positive infinity, y is going to approach negative infinity. So it's going to end this way. And with that, I can now just connect my dots. So starting from quadrant 2, I'm going to head down towards -5, but it's a point of inflection. So I'm going to take that little pause and change my concavity. Then I have to turn around somewhere halfway-ish to go to -3. And at -3, I'm going to bounce off the x-axis. Then I have to start turning back towards the origin. And here I'm just going to pass through. And then I'm going to head to 1.5 to bounce off the x-axis until I finally go back to 4 and pass through. The way I applied my bounces and passes and all of that fit with my end behavior, so I don't have any red flags here, which is great. And now just looking to see here, state the intercepts I did. I need to do the domain and range. My domain and range are both infinite. The domain is always going to be infinite, but the range, if it were an even degree, because the end behaviors would both be going positive or both be going down to negative infinity, I wouldn't give a range for a polynomial just because we don't actually know where the accurate local max and mins are or the absolute ones, so we wouldn't be able to do the range. Unless you know calculus, then you would be, but that's not in this course. So that's my domain and range. I did my end behaviors already. And then the last little piece here is a little inequality. I graphed the function, so I should be able to state when f at x is less than 0. If it's less than 0, that means I want to be in the negative region. So between -5 and -3, I'm less than 0. Between 3 and 0, and then from 4 onwards. So f at x is less than 0 for the interval where x belongs to -5 to -3, and -3 to 0, and 4 to infinity. And you'll notice that I broke up -5 to -3 and -3 to 0 because the inequality says less than 0, not equal to 0. At exactly -3, that's an x-intercept. F at x is equal to 0, so that doesn't satisfy that inequality. So there it is. A little graphing refresher with all the fancy behaviors around the x-intercepts. Talked about degree, leading coefficient, a few important properties here, and a little inequality twist in there as well. Okay. Any questions with this first graph before I go to a rational graph? And please, as I'm going through, if you do have any questions, just let me know in the chat, or if you feel comfortable turning on your mic during the recording, you're more than welcome to do that as well. Okay. But if there aren't any questions, we'll hop into the rational graph. Okay, so I have a graph, a function here, g of x, in the typical rational format that we see, which is -3x plus 2 over 5x plus 10. We're going to state the intercepts, the domain, range, the end behaviors, and we're going to graph it. So first thing, I'm going to figure out my intercepts. So, my x-intercepts, regardless of the function, whenever you're looking for an x-intercept, you're just setting your function equal to 0. But when we do that for a rational function, if I cross multiply, 0 times the denominator will be 0. So our x-intercepts always came from the numerator. Okay, so I'm going to set my numerator equal to 0, and then I'm going to isolate for x, and I get 2/3. So my x-intercept is 2/3, 0, and I'm going to go and plot that point as I find things. Then for the y-intercept, I'm going to set x equal to 0, so that means I'm solving for g at 0. And I'm not going to show my work here, but when I set the x is equal to 0, it cancels out 3x and 5x, so it's 2 over 10, which is 1 over 5. So 0, 1 over 5, and 1 over 5 is 0.2. So I'll plot that point roughly. Here it is. Okay. Now I still need more information to graph because obviously 2 points aren't enough, and we know rational functions have asymptotes. So I'm going to find the vertical asymptote next. The vertical asymptotes match up with the restrictions of rational functions, and restrictions come from the denominator because we cannot divide by 0. So you can set your denominator equal to 0 and isolate for x. So bring the 10 over and divide out the 5. So x equals -2 is my vertical asymptote, and I'm going to go ahead and highlight. Okay. Then we also have horizontal asymptotes. And horizontal asymptotes, we look at the leading coefficient of the numerator and denominator. So the coefficient of x in the numerator is -3, and the coefficient in the denominator is 5. So -3 over 5, which is -0.6. So I'm going to go ahead and highlight that asymptote. Okay, so we have all of that there. We have 2 points. It's looking good. I mean, I have an idea that this is the shape that I'm gonna have, but maybe I want a little bit more proof. So we can find some more key points by finding a point to the right and a point to the left of the vertical asymptote. So if my vertical asymptote is at -2, I'm going to evaluate g at -3 and g at -1 just to get a little bit more information here. So I'm just going to do that. Negative 3 times negative 3 plus 2 over 5 times negative 3 plus 10. And I got negative 11 over 5, which is negative 2.2. So I'll plot that point. Negative 3, comma, negative 2.2. There we are. And that just gave me enough proof that I'm in this specific quadrant. So I must follow my asymptotes like this. If I wasn't sure, I could always find more key points. And then for negative 1, negative 3 times negative 1 plus 2, 5 times negative 1 plus 10. And that was 1. So negative 1, 1. And on this side, I didn't really need more points. I already had an idea of what this would look like, but there we are. There's my graph. So I found asymptotes, I found intercepts, found a few extra points, and now I can do my domain, range, and my end behaviors. So the domain is almost infinite, except I have that vertical asymptote in the way. So a negative infinity to negative 2 and negative 2 to infinity. And for my range, y can be anything except that horizontal asymptote, which was at negative 3 over 5. So I'm going to go from negative infinity to negative 3 over 5 and negative 3 over 5 to infinity. So domain and range are done. Now, in terms of our end behaviors, as x approaches negative infinity, so as I'm going to the left forever, I'm following or approaching the horizontal asymptote. So y is approaching negative 3 over 5. And to show that I'm approaching, excuse me, the asymptote from below, I'm going to put a little superscript that's negative to show that I'm coming from below the asymptote. And then as x approaches positive infinity, so as I'm going further and further to the right, again, I'm still approaching that same horizontal asymptote, but I'm approaching it from above. So I'm going to put this little plus on top. Now, I think we only did end behaviors like to the infinities for rational. I don't remember exactly if it was in D2L or if I talked about it, but technically there are end behaviors around the, I think I did, I don't remember, to be honest, around the vertical asymptote as well. So I'm just going to add 2 more end behaviors here, and it's going to be the behavior to the left and to the right of the asymptote. So I'm going to say as x approaches negative 2 from the left, so I'll put a little negative on top, and as x approaches negative 2 from the right. Okay, what's happening? Well, on the left side, I'm going down forever. So y approaches negative infinity. But on the right side of the asymptote, this piece is going up forever. So y approaches infinity. So it's like I have an end behavior for each of the arrows on my function. I have an arrow here, 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 and here. Okay, and there we are, a little graphing review for rational and properties review. Okay, any questions about the rational graph before I do a little bit of solving refresher? Is it the coughing sound? I'm sorry about that. What sound do you hear, Ralph? Maybe my microphone is in a fuzzy place. Oh, that was an email that just came in through on my end. So maybe it was that, if it was a ding. Yeah, no, sorry, that was my email. And I have my volume kind of blasted, so that's why. So your computer's fine. All right. Okay, so perfect. So my next example, I have 2 more for tonight. I'm going to do a polynomial equation where I have not factored. That way we can refresh on, our synthetic division, our factor theorem. And then I also have a rational inequality so that we could refresh on rational solving and the sign analysis. Okay, so starting with the polynomial equation, we need to make sure that one side is equal to 0. So first thing I'm going to do is move things over. Okay, and collect our like terms. So what we're actually solving, 3x to the 4 minus 4x cubed minus 17x squared plus 2x. The 3's cancel out, and here we are. And now to solve, we have to factor, and always look out for a GCF first to make your life easier. All of these terms are divisible or have an x in common, so I'm definitely going to factor an x out because turning this into a cubic means I only have to do synthetic division one time instead of two, and that sounds great. Now, remember when you're factoring, you want to try to find a factor of the remaining bracket. And the way you do that is by subbing in different factors of your constant until it spits out 0. Because remember, whatever value you sub in represents the answer that you get represents the remainder. Okay, if you were to divide. So if I were to sub in 1 into 3x cubed minus 4x squared minus 17x plus 2, I got negative 16. That means if I divide that cubic by, what did I just say, by 1? So by x minus 1, the remainder would be negative 16. Now, if I'm trying to factor something, I want the remainder to be 0. So 1 was not a great option. I could try negative 1. But when I sub in negative 1, I get positive 12. That's still not a good option. And obviously, I don't want to go through all the numbers on a number line. So to figure out your potential options, first, try all the factors of the constant. So that's plus or minus 1, which I already did, plus or minus 2. But also, you can look at combinations. So if I take 3, the factors of 3 are 1 and 3. So I can take these values and divide them by 1, which is those values, or divide them by 3. So I can also have plus or minus 1/2 and plus or minus, sorry, not 1/2, 1/3. So 1 divided by 3 and 2 divided by 3. Those are the only options that I can test for my factor. So it's not an infinite number of options, but usually it should be one of the nice clean factors. So I'll try 2 and negative 2. So if I try 2, I got negative 24, so that's no good. I'll try negative 2, so 3 times negative 2 cubed, minus 4 times negative 2 squared, minus 17 times negative 2 plus 2. Okay, did I write something wrong? It's 4? Did I factor something wrong? Four. I believe you, Ali, but that just doesn't seem to make sense. When I put 4, okay, hold on everyone. I changed the question today, so maybe I gave myself a typo. Okay. 3x to the 4 minus 2x cubed minus 17x squared. Oh, shoot. It was supposed to be plus 5x. Okay, quick edit. Sorry, everyone. Okay, that should have been a 5, which would make this a 6. Okay, let's see if that fixes it. So as you can see, this part can be a little annoying. Okay, there we go. So negative 2 does work once I made my correction, because I don't know why I erased the 5 earlier. Okay, so when I typed in -2 for all the x's, I got 0. So that means x plus 2 is a factor of the cubic, okay, of the part in the bracket. So now you can do synthetic division or you can do long division, whichever you prefer. I prefer synthetic because it's quicker. So if x plus 2 is the factor, I'm going to put -2 out front, and inside the box I'm putting all of the coefficients. So that's 3, -4, -17, and +6. And remember, if any of the coefficients were missing, like for example, if there wasn't an x squared term, I would have to put a 0 for that coefficient. Every coefficient needs to be taken into consideration. And now for the synthetic division, first step, I'm going to drop the 3 down, and then I'm going to do 3 times the factor. So 3 times -2 is -6. Then add the column. -10 times -2 is 20, and then add the column. 3 times -2 is -6. Add the column. You get 0. You want 0 because that means it was a factor. You need that remainder. So now, when I continue, don't neglect the GCF or any factor you already found. There's the GCF. Here's the x plus 2 factor that I worked for. And then these coefficients represent the coefficients in your quadratic, because if I'm dividing a cubic by a linear, the leftover is quadratic. So I'm going to have 3x squared minus 10x plus 3. All of that's going to equal 0. And then I can factor the remaining trinomial. I'm going to do a little crisscross here, but you could do whatever method makes you happy. So this is good. It adds up to -10, multiplies to 3. So that means I'm going to have x times x plus 2 times 3x minus 1 times x minus 3 equals 0. And now that it's factor, I can solve each of the brackets. So for this one, x can equal 0. For this one, -2. You're really just finding the zeros now. Those are your solutions. But we don't have to do the graphing because this was just a solving question. And there we are. There's us solving a polynomial function. And sometimes when you're solving, you might need to do your synthetic division and factor theorem twice if you started with a higher degree. Like if this leftover bracket, once I did my GCF, was quartic to the power 4, then I would have to do one factor and synthetic division to go from quartic to cubic. Then I'd have to do one more to go to quadratic, and then I can finish with a quick quadratic factoring. And there it is. If this were an inequality, I would go ahead and do my sign analysis using the x-intercepts and the factors on the side. Okay, but I am going to go over the sign analysis just with a rational function, because the rational function sign analysis is a little bit more interesting than the polynomial one. So before I go to the rational inequality, any questions about the polynomial solving, the factoring? All right. Okay, so then we'll hop into our final example for the night, which is a rational inequality. I chose an inequality because it requires a little bit more work. It's a little more interesting with the sign analysis. But of course, we've also done rational equations. I would do a little bit of cross multiplying and solve from there if it were an equation. For an inequality, we do not touch cross multiplication. Step 1, make sure one side is equal to is 0, which we already have. If one side was not 0, we would have to bring that rational function over, get a common denominator to make it look like what I already have set up. Once we have a fraction is greater than or less than 0, then we are going to factor that fraction. So In the denominator, I'll just do that one first because it's a little quicker. Here it is. In the numerator, I'm just going to do a little crisscross on the side. 3x times x is 3x squared. 4 times negative 2 is negative 8. That's 12x. That's negative 2x. That adds up to 10x. Fantastic. Okay, so now I'm fully factored. Now, I need the x-intercepts, just like with a polynomial, but I also need vertical asymptotes. So my x-intercepts are 2/3, 0 from the numerator and negative 4, 0 from the numerator, because we know x-intercepts come from the numerator. And the denominator gives us the vertical asymptotes, which are at negative 2 and positive 1. These are the places where your rational function can go from positive to negative or the other way around. So these are the values I'm going to put in my number line for my sign analysis. So on the side I'll put the factors, but I'm going to go from negative infinity to, my first value is this x-intercept of negative 4. So that's going to be one interval. Then I'm going to go from negative 4 to the vertical asymptote, because that's the next number on the number line. And I'm just going to make a little note here that at negative 2, we had a vertical asymptote. Then I'm going to go from negative 2 to 2/3. Then I'm going to go from 2/3 to 1, 1 being a vertical asymptote. So I'm going to put a reminder for myself, just because I tend to forget things, so I like having the reminders. And there we go. Now I have all of the intervals between my x-intercepts and my vertical asymptotes. And now on the side, I'm going to write out all of the brackets from my fraction. 3x minus 2, x plus 4, x plus 2, x minus 1, and then the last one is just overall. And now I'm going to pick a test value within each interval and sub it in to each factor. So I'm going to start with 3x minus 2. I'm going to sub in negative 5. That's going to give me negative 17, which I don't care about. I just care that it's negative. Between negative 4 and negative 2, I'm going to pick negative 3. That's also going to give me a negative, negative 11. Between negative 2 and 2/3, I'm going to pick 0 because that's quick. That's going to give me negative 2. Between 2/3 and 1, 2/3 is 0.6 repeated, so I'm going to pick 0.7, which is now a positive number. And then I'm going to try 2. That's also a positive number. And I'm going to do the same thing, pick my test values and sub them in. So negative 5 gives me negative, negative 3 positive, and then I'm positive the rest of the way. Negative 5 gives me a negative, negative 3 gives me a negative, 0 gives me a positive. Positive the rest of the way. Negative 5 gives me negative, negative 3 negative, 0 negative, 0.7 still gives me negative, 2 gives me positive. And now I'll evaluate the overall sign. 4 negatives in the first column give me a positive, 3 negatives give me a negative, 2 negatives give me a positive, 1 negative, negative, and positive at the end. Now after all of this work, I've already forgotten what it is I was solving for, so I'm going to look up. I want to be greater than or equal to 0. So I want to be positive or an x-intercept. Okay, definitely not a vertical asymptote. I'm not allowed to touch that. That's not a value. So when I write my final interval, x belongs to, so I want to talk about negative infinity to negative 4. Negative 4 is an x-intercept, and I want to be greater than 0 or equal to 0. At negative 4, I am equal to 0. So I'm going to put a square bracket because negative 4 is included in my answer. Then I want to be from negative 2 to 2/3. I am not putting a bracket on negative 2 because that's a vertical asymptote. I cannot have a value there. but on the 2/3, which is an x-intercept, I will put a square bracket. And finally, from 1 to infinity, we're positive. 1 is a vertical asymptote, so it will take a round bracket. And there we are. So we refreshed on the sign analysis, okay? We refreshed on the fact that a rational function, you have to take not only x-intercepts into consideration, but also the vertical asymptotes. And also, it didn't happen in this example, but if I did have fractions on both sides, make sure you bring them both to the same side, get a common denominator, and then go down to your factoring step, okay? So I just wanted to do a little bit, touch on a few different things. Just, it's been a while since we did polynomials and rationals, so I just wanted to hopefully trigger some memories for you about how to solve and how to graph. So from here, obviously, we did more than just this, but it's just a starting point for your review. At this point, you want to go do more practice, refresh with your notes, look over your test just to see more types of examples, and make sure you are studying and practicing all the different styles of questions and ideas, okay? Any questions for me? Anything else related to polynomials or rationals that you want me to go over, refresh on? Please let me know. All right. So I'm just going to stop the recording here.